Hello everyone. So today's question is from codechef contest starters 117, which is conduct on 17th January. Problem is equality etiquette. Okay. So the problem this statement is you have two integers a and b and you would like to make them equal. To this end, you can perform several moves on the ith move. Okay. So if I is odd, either add I to A or add I to B. Note that you are not allowed to add I to both and must choose exactly one of them. Okay. And second case is if I is even, either subtract I from A or subtract I from B. Once again, you are not allowed to subtract from both and must choose one. Okay. And find the minimum number of moves needed to make A and B equal. Print -1 if they can never be make equal. Okay. So let's understand this question. What is it saying? Basically, this question is saying that we have two integers a and we have to make them equal and minimum moves. So what is our moves? Whenever our move is odd, we can add the move number in A or B, and whenever our move is even, we can subtract move number from A, either from A or either from B. Okay, so let's understand this with the example. Okay, so we have initially two integers A comma B, and we have to do, let's say, n moves, and we have two cases. If we are on ith move, okay, so if I is odd, we can say that A plus I or B plus I, and if I is even, we can do A minus I or B minus I. Okay, so basically, let's say we have A equal to 1 and B equal to 5. So in 1 and 5. So let's say in first move, we have two options, add 1 in 1 and add 1 in 5. So if add 1 in here, two cases, we can say 2 comma 5 and 1 comma 6. Okay, now second move. Then second move, again we have two options for each case. We can subtract 2 from 2 comma 5 and we can subtract 2 from 5. So 2 comma 3. Here we can subtract 2 from 1, so minus 1 comma 6, and we can subtract 2 from 6, 1 comma 4. Okay, so now next is third move. Okay, then third move again we have two cases for each case, so we can add 3 in 0 or we can add 3 in 5. Here we can add 3 in 2, so here this is 5 3, and we can add 3 in 3, 2 comma 6. Okay, now in this we can add 3 in minus 1, where 2 comma 6 and minus 1 comma 9, and we can add 3 in 1, 4 comma 4, and if we add 3 in 4 and 1 comma 7. So here in these cases, in these all the cases, we see that 4 comma 4 in third move, our both numbers are become equal, equal to b. So in three moves, we can say that we can equal our both numbers. So our output is 3. Basically, this is a brute force logic. We have to think more about this because we cannot apply brute force. It takes so much time and it shows TLE. Okay, so let's say our example is 1 comma 5. Now understand. Now see the gap. Okay, what is gap between these two numbers is 4. So what we are doing in a first move, we can add 1 is in this and we can add 1 in this. So if we add 1 in this number, we decrease gap by 1, so gap is equal to 3, or we can say that if we add 1 in this number, our gap is equal to 6. Okay, sorry, gap is equal to 5. Now in second move, when gap is 3, 2 comma 5 and 1 comma 6. So in 2, let's say gap is 3. So we can say that we can we can subtract 2 from 5. So our gap is decreases by 2. So gap is 1, or we can increase our gap by 2 in second move. So gap is 5. In this case, we can decrease gap by 2, or decrease gap by we can increase gap by 7. Okay. So we both we are doing. Basically in ith move. Okay. We can reduce our gap by I, or we can increase our gap by I. This is volt. And in question we have to reduce our gap till 0. Okay. Now we will work on gap only. So let's say okay, now we work only on the gap. So let's say we have another example. A is equal to 1 and b is equal to 10. Okay, so our gap is 9. So in first move we reduce our gap by 1. 9 minus 1 equal to 8. Because why we reduce only? Because we need gap is equal to 0. Now in second move we can reduce our gap by 2. It's 6. In third move we can reduce our gap by 3 equal to 3. Now in fourth move If we reduce our gap by 4, it is equal to minus 1, and we want only gap equal to 0. So we cannot do this thing. Okay, so here we have gap 3. So if here we have gap 4 or we have gap 9. So if we have 4, then we can reduce by 4 in fourth move, and if we have 9, we can reduce by 4 in fourth move, and we can reduce by 5 in fifth move, and we will get 0 gap after fifth move. Okay, so let's say in first move we do not reduce it, we increase it. So our overall gap is increased by 2 in all the cases here. 9 plus 1 equal to 10, 10 minus 2 equal to 8, and 8 minus 3 equal to 5. So this is also increased by 2, but we need only 4 or 9. Okay, so we do not change the first move. Okay, now let's say we uh, we do not reduce our gap 2, our gap by 2 in second move. We increase this. So 8 plus 2, which is equal to 10, and 10 minus 3 equal to 7. Okay, so here again we do not get 4 or 9, so we do not took these things also. Now if we increase our gap by 3 in third move, then what we get? 9, and there we want only 9. Okay, so what we did when we have a gap of 3 and we are on our fourth iteration. Okay, what we need? We need gap 4 or 9. Okay, so in third iteration, before this iteration, in third iteration, we reduced our gap by 3, and if we increase it by 3, here our total overall gap is increased by 6, because if in this uh, we can do gap plus 3 in third iteration. Okay, so we do gap plus 3, so this is increased by 6. So this overall gap is increased by 6. So 3 plus 6, 9. So after 9, we need only two iterations, fourth and fifth. Okay, now let's say in any other example, we have gap 3 and we are on our fifth iteration. Okay, so fifth, what we want? If our gap is 5 or if our gap is 11, then we can say if gap is 5, we can make it 0 in fifth iteration, and if our gap is 11, we can make it 0 in fifth or sixth iteration. Okay, so try to make it 5. So what we can do in our first iteration, what we did gap minus 1. If we did it gap plus 1, okay, so we increase our overall gap is by 2, so we can increase it by 2, and here we got 5, and we can reduce it in fifth iteration. Okay, so what we can do? In first move here, we can increase our gap by 2. In second move, we talk about after all iteration, we talk about this gap. Okay, this gap. Second move, we can increase by 4. In third move, we can increase by 6, and these all moves are done. Means ये moves पहले ही हो चुकी है. Okay, and we are for fifth iteration, so in third move, fourth move, we can increase our gap by 8. Okay, so these we can do. So if our gap is 3, in ith iteration, what we want? If our gap is I, or if our gap is I plus 1. So if I is odd, okay, if our I, so we can add only even number in 3. So if our I is odd, we can easily add any even number and make it I. And if our I is even, so it is even and it is again odd, and we can add this. We can make it odd again because it is odd if I is even. So if I is even, we need, if I is even, we need 2 more iteration. Okay, and if I is odd, we need 1 more. So this is the condition which we make if gap is odd. Now let's see that our gap is even. Let's say our gap is 4 and we are on fifth iteration. Okay, so what do you want? If our gap is 5 or our gap is 5 plus 6, or our gap is 6. Now why 6? Okay, so we if we in fifth iteration, we can reduce this 6 by 5, which is 1, and 1. What we can do this one in sixth and seventh iteration, we can make it 0, because in sixth iteration we can add 1, we can add 6 and 1, and in seventh iteration we can minus 7, so it becomes 0. We talk about gap, not A or B. Okay, so don't confuse that we add 6 or we minus, we subtract 7. Okay, we can plus minus, we can plus gap or we can minus. Okay, so here what we see, like our gap is even, and we are on odd iteration. Okay, so in this case, we need three more iterations. Three more iteration. Okay, and if we are on even iteration, so we need only one more iteration because if our gap is 4 and we are on sixth iteration, we can make it easily 6. Okay, how we can make it 6? And first move, what we did, gap minus 1. So here, what we will do, gap plus 1. So our overall gap is increased by 2. So here, it increased by 2 will become 6. And in sixth iteration, it will become easily 0. Okay, so here, our next condition. So till now, we got three conditions. We have to find that iteration at which if we have on ith gap minus I become negative. Okay, this is first. And if after this, if our gap is even, so we see that if I is even, we need one more, and if I is odd, we need three more. Okay, and if our gap is odd, so our I is, if our I is even, that is the condition for this. Let's see. If I is even, we need two more iteration, and if I is one more. Okay, so if I is even, we need two more, and if I is odd, we need one. Okay, so these three conditions which we have to follow. So let's code this question. I'll take all the inputs. I will take all the inputs, and now we calculate gap. Long gap is equal to, this is gap is absolute value in my dot APS A minus B. Okay, now we have to find these iteration. Okay, and this gap after all, after what we do, what we want, we have this I and gap after I minus 1 after 1 minus I iteration. Okay, so we need this gap. So what is I minus? So the sum of till I minus 1 is equal to I minus 1 cross I divided by 2. Okay, so we have to find this. What we do? Okay, so first I will take a I, which is initially 1, and before this, if our gap is already 0, then we can simply print 0. Because our answer is 0, we do not make any move. So our answer is 0 and continue this loop. Okay, so after that, while our gap minus I is less than 0 or is greater than equal to 0, then what we do, we decrease our gap by I and we increase our I. Okay, so here we got I minus 1 iteration. So our number of iteration equal to I minus 1. Okay, now we apply these conditions. After that, if our is gap is even, so what is the condition for even? If our gap is even, we have to visit I is even or I is odd. So if I is even, what more iteration we need? 1. So we can increase our iteration by 1. Else, what is I is odd? We need 3 more iteration. So it plus equal to 3. Okay, and here we have to write if here our gap is 0, we do not need any iteration. So we can simply print our it and continue. Okay, after that, if our gap is odd, then if I is even, we need 2 more. If I is odd, we need 1 more. So if I is even, then we need 2 more plus equal to 2. Else, we need 1 more. Okay, and we can simply print our iteration. System dot out dot println iteration. So let's run this code. Let's show some okay. That is if. Now let's run. When compilation error screener C class screener. but it is showing some error scanner. Okay, line number 9. Teacher height is okay. Spelling thing. Oh, let's run. So our output is accepted. Now let's submit the code. It is time limit exceed TLE. Okay. So here our time complexity is bigger. We have to reduce this. So what we can do here, we can apply binary search. Okay. What we need in binary search, we need start. So we have to start from s. So s equal, we need to start from 1 and our end is cap. Okay. Now let's say after this our answer is, our answer is 0. Okay. So while s is less than equal to 0, is that our, what is our mid equal to s plus e minus s divided by 2. This is our mid, and now we need this condition. Okay, let's say till mid, our, and what is addition, till mid long k equal to first first n numbers summation mid plus 1 divided by 2. So this is the formula for mid first n number summation, where m is mid. Okay, n plus 1 divided by 2. So now if our cap minus k is greater than equal to 0, what it means, our k is less than gap, means we need more iteration to make gap, and we store this k also in our answer. Okay, so we say that answer equal to math.max answer comma k, and we increase our I made plus 1, and we can increase our starting point also by mid plus 1, and else our cap minus k is negative, then we uh, backward, we move backward. So our end is equal to mid minus 1. Okay, so here we found mm, these cap and these I with the help of binary search. Okay, now let's run this code. This is how it is missing. Okay, so we can here simply make a condition if our cap is equal to 1, then we can simply say that our output is 1. Continue. Okay, now let's run 0154. This is accepted output. Now let's submit this code. Show wrong answer. Okay, okay. So here we have to change our cap. Okay, so we take initial gap here, but we have to take gap minus uh, this gap after ith iteration, I minus 1th iteration. Okay, so now let's submit this code. So our code is submitted successfully, and here you can see your code. I maximize this. You can see the code. This is Java code, or you can change this to CPP. Okay, thank you for watching.